Okay, like I was saying earlier, we are going to illustrate test of hypothesis for regression analysis. Now, what I'm going to present today will just be uh, the calculation of slope and intercept, the standard error of B, and the hypothesis testing for regression analysis using summations. And this is what you're going to see in your exam. You're not going to see a spreadsheet where you're going to do all those calculations. You're simply going to see the summations, the summary values of the variables. And then you just go in to plug in the formula. And then after you plug in the formula and you calculate the slope and intercept, you're going to plug in the formula for the test of hypothesis. And so it's going to be pretty straightforward on your exam. And this is what I'm going to illustrate today. All right. I'm going to start with a couple of examples. All right. I'm going to share my screen, and I'm going to explain the problem we're going to try to solve. Then I'll paste in all the numbers, and then we're going to do the calculation with the summaries. So I'm going to share my screen right now. I'm going to share a blank screen. Okay, so this is a blank screen of a PowerPoint slide. I'm going to begin with a simple problem. This is a test of hypothesis wages as a function of education. So the question is, does education affect wages? That is to say, if you have more education, do you have more wages or do you have less wages? Or can we argue that education does not significantly affect wages? So the equation will be that y is a function of x, or specifically, wages depend on education, all right? Or you can say education level. The more education you have, the higher your possible wages. And so we can rewrite the equation as wages is equal to A plus B times education. That is to say, if you come to a workplace, there's a basic wage you're going to get, even if you have no education. And the more education you have, your wages will change. So we include an error component. Now, in regression analysis, we say that wages will be the dependent variable y, and education will be the independent variable x. Okay, that's what we call it. Y is a function of x. All right, so what formula do we use? I'm going to put together the formula here. We had done this in the past. So I'm going to put out the formula. So our objective here is to estimate B, the slope, and we estimate A, the intercept. Okay, so we estimate the intercept, and we estimate the slope. B is the slope. So if your education goes up by 1 year, how much would your wages go up? Okay, so this is the basic formula. Okay, we estimate A using A hat, and we estimate B using B hat. So how do we go about that? Now, what I have done is to set up these summations. The summation y minus y bar times x minus x bar, and I have y bar and I have x bar. So I'm going to put them up, and then we calculate, we estimate B using B hat, and we estimate A using A hat. So how do we go about that? I'm going to pull up the information. All right. So now you have all the numbers. Okay. You have all the numbers. You have the summation y minus y bar times x minus x bar. You have the summation x minus x bar squared. You have the summation y minus y bar squared. And the last summation y minus y hat squared is what we're going to use to test our hypothesis. So you're going to see how we test the hypothesis using that information. Now, first of all, we have to estimate B hat. So now, how do we estimate B hat? We have the summation y minus y bar times x minus x bar. So we simply plug in that number. I'm going to plug it in. Okay. We have the number here. Summation y minus y bar times x minus x bar. We take it in. All right. And summation x minus x bar squared. We have it here. We plug it in. And so be it. So we have that. Can somebody help me with the calculation of B hat? Hello? You guys hearing me?
I'm doing it.
All right, fine.
I have 2477.0947271.
Okay, that's correct. 2477.094. 2477.094.
271.
All right, so I'm just going to take that. Okay. So, all right. Now, let us calculate A hat. Okay, you have Y bar, which is so that for 2 Y bar, which is 30833, 30833.46 minus 2477.094 times 12.73, and that gives us what?
I have negative 699.94662.
Okay, negative 699.
0.94662.
95. Okay, I'll just abbreviate it to that. Okay, so now once you do this, then you're going to write out the model equation and interpret it. You have to write out the model equation and interpret it. A, now remember that the model is A plus B times X, okay? A plus B times X. So A hat is minus 699.95 plus, because 2477 from our calculation is a positive number, okay, plus 2477.094
177.14738.
times X.
What time X? Okay.
Let's see. All right.
Okay.
So,
okay. See what you're saying.
So now that is your model equation. What does that model say? What does that model say? What it says is that if you have no education and you come to this particular workplace, this does not apply to every workplace. This sample was taken from a particular business or a particular company, a particular establishment, or even particular industry, okay? For example, suppose you are taking a sample of, say, high school teachers or college professors or elementary school teachers. Suppose you never went to school and has zero education. What happens? You're not going to get paid at all, okay? You're not going to get any penny. But for each additional year of schooling, your wage will go up by 2,477, which is the slope, the B hat. The B hat is the slope. So this is what this model says, all right? Now, the next thing then is here it says no education equals no wage. And for each additional year of schooling, wages will increase by 2,477 and 9.5 cents. Okay, this is what the model equation says. Okay, this is what the model equation says. And so when once you do the estimation, you have to state the model equation, and then what is the meaning of that model equation. Now, the other question then we ask for us is, does education truly, now remember, once you do an estimation, you're going to get some numbers, but those numbers don't mean anything until you do a test of hypothesis to ask yourself the question, does education truly significantly affect wages? Does education truly significantly affect wages? So now you do a test of hypothesis, all right? You do a test of hypothesis. And so I'm going to use the next set of numbers to do a test of hypothesis, and I'm going to put up the formula, okay? I'm going to put up the formula for that. We have all the information that we will need for doing that. All right. Test of hypothesis for B hat, okay? This is test of hypothesis for B hat. All right, now in order to test a hypothesis for B hat, you have to state a null hypothesis. Now, your null hypothesis will be that education does not affect wages. So you state your null hypothesis, okay, which is that B is equal to 0. Education does not affect wages, does not significantly affect wages, okay? The alternate hypothesis and B is not equal to 0. Okay. The alternate hypothesis will be that B is not equal to 0, which says that education does significantly affect wages. Okay? So your null hypothesis is that education has no effect. The alternate is that education does have an effect. We test at, I'm going to select the level of significance. I'm going to use 0.01 level of significance. Okay. We have a large sample size, so Z is equal to 2.33. Okay. We use a Z of 2.33. That's our level of significance. So now we have to calculate Z. Okay. So Z star, which is our critical value. And now remember, if you have a problem, you're going to have to actually find your own Z star. This is number one. And if you have a small sample, your T is going to be different. So for now, I'm using a large sample. For this particular problem, N is equal to 100. Okay. N equals 100. All right. And so to test the hypothesis, To test the hypothesis, we have to calculate a z. Now we have the critical z value. We have to calculate the z that we're going to compare. So z for the test of hypothesis for the slope, you calculate z is equal to okay, which is b hat minus b. We're going to come here and get b to b hat b hat minus b, and we know that b is a 0 divided by the standard error of b hat. All right. Okay. Now, what does this mean? Okay, z is b hat minus b divided by the standard error of b hat, which is equal to what? Now, we're going to have to calculate the standard error of b hat. So I'm going to calculate the standard error of b hat. The standard error of b hat is calculated. And again, this is one of the things I'm going to test you on. So I'm going to give you the formula for the standard error of b hat. And you have to be able to plug in this standard error. Okay, so this is the standard error of b hat and the way it's calculated. So we're now going to use this information to to do a test of hypothesis. So we're going to calculate the standard error of b hat. You have summation y minus y hat squared. It's right here. You have the sample size is 100. So n minus 2 will be 98. And you have summation x minus x bar squared. And that is right here. Okay, so let's do an equality sign. And summation y minus y hat squared. Where do we have it? Right here. So we're going to take that. Okay. And n minus 2 will be 100 minus 2, which is 98 times summation x minus x bar squared, which is there. Okay, 98 times that. So can somebody help us with that calculation?
Professor,
Yes, sir.
am I making a mistake?
Okay.
Okay, is x minus x? Okay. I found that. That's a summation of x minus x
Bar squared.
bar square, right? Okay.
Which is right here.
All right, I do it now.
Okay. And then n minus 2, which is 98. So you have to, all right. And so what is that calculation? And
236
799
89
6987
divided
okay over 771.71
98
over 98 okay
8 times 771.71.
okay. So what do you get?
I'm trying to find the square root.
Okay, Mr. Henry, welcome. You have an answer for us?
I'm looking for the square root of 3,133.
All right.
Professor, is it 55.977?
I don't think so.
I'm not getting it.
So what do you get, Ahmed?
I'm getting 43186.173.
Well, I think we have some discrepancies here.
43186. I could start over again.
I got 55.977.
2369799.
Looks like we are running into some discrepancies here.
89. Square root of 23697996987.89 divided by 98 times 771.710. I have 1.597. Is that right, Professor?
Okay, first of all, we are looking for the standard error of B hat. Is that correct?
No, I did everything together.
Okay, first of all, let's look for the standard error of B hat. That is the key thing here. Okay, 559 point. What did you say you got?
Yeah, I
got 1.5974.
55.977.
Yeah, 559.777. That is the standard error of B hat.
That's it, right, Professor?
Yes, that is what we should have. Okay. The standard error of B hat first. Okay. 2, 3, 6, 9, 799, 6987, 98, 771. Power.
8.
Okay, it's 599. Okay, so friends, what did you say? It's 599 what?
Yeah, I got
599.777.
Yeah, 55.977.
Okay, so that is the standard error of B hat. That is the first thing you need to know first. Okay, once you get the standard error of B hat, so let's get that squared off. So we have the standard error of b hat. Then we're going to apply. Excuse me, guys. We're going to now calculate z from it.
Non, c'est pas obligé que je sois jugé. La voiture n'est pas mon. Mais ça reste chez toi si je viens pas. Si tu pars pas là-bas,
Please, no sidebars, no sidebars, no sidebars. Okay. Now, z is b hat minus b. Well, the hypothesis for b is a 0. So it will be b hat minus 0. And b hat is what? B hat B hat is 2477. Is that correct?
It's on the other slide, Professor. If you go back to the others.
2477.094.
That's correct. Yep.
Okay. 2477.094 minus 0. And the standard error of B hat is 599.777. And so what is the result? 2477.094 over 599.
24.
It's 4.13.
4.13. 4.13. So that is Z. That is the calculated Z. So now you have to compare this calculated Z to Z star. Okay. So the decision rule.
Sorry.
So we go to the decision rule. Okay.
It's greater than Z star.
If Z is greater than Z star, we reject the null hypothesis. So I'm going to copy that. I'm going to put it right here. So decision rule and decision. Decision rule and decision. All right. So I'm going to try to be a little parsimonious here. All right. If Z is greater than Z star, we reject the null hypothesis that B is equal to 0, which implies no effect. Now, you see, I'm trying to clarify this whole thing, but what null hypothesis you set up and the meaning of your rejecting the null hypothesis, okay? Because that confuses students a lot, including me when I was a sophomore. Your null hypothesis is that B is 0. Education does not affect wages. That's what you are saying. So if Z is greater than Z star, you reject that null hypothesis that B is equal to 0. And in this, for this, what is our decision? Our decision is that Z of 4.13 is greater than Z star, which we know is 2.33. And that means we reject the null hypothesis that B is equal to 0. And what is the implication? The conclusion is what? What is your conclusion? Your null hypothesis is that B is 0. Education has no effect. The alternate hypothesis is that B is not 0. Education does affect wages.
Will affect.
So your conclusion is that B is not 0, which means what?
The education does have a
Education does have effect on wages. Okay. Education affects wages significantly. And in this particular problem, you are saying that the more education you have, the more wages you get. Now, why do you say that? Why do you say that the more education you have, the more wages you have? What leads you to that conclusion?
Our hypothesis. Well, the decision.
Well, the equation of the model. What is the equation of the model? The equation of the model is wages equals, right? 699.95 negative plus, because the slope, the rate of change of your wage with regard to education is a positive number.
Excellent. I missed that part, Professor. I came in late. Would you provide that to us, or do we have to figure that out?
You figure it out through the estimation of B hat.
Oh, I have to go back and check that out. Okay, I missed that part.
Okay. When you estimate the equation, remember you have your equation here. The equation is wages is A plus B times education. So if A is 0 or like a negative number, it simply means that when X, it simply means that if you have no education, right, you get nothing in this particular business. If you have no education, you get nothing. But for every 1 year of additional education, your wages will increase by B. Now, if actually your wages will change by B. So if B is positive, it means your wages will increase by B. If B is negative, it means your wages will reduce by B. So now, after you estimate the equation, you estimate B hat, which is your slope, and you estimate A hat, which is your intercept. That intercept simply means even if you have no education, you will get something, but it's going to be small.
Yeah, I see what you're saying.
But this model is actually saying if you have no education and you come here to work, you probably have to pay. Maybe you're learning, right? But for each additional year of education, your wages will increase by 2477. You get it?
That's a good example. I see how you said it with the education. Thank you. Yes. That's a good example.
So, but this 2477, you're going to estimate it. This is why you estimate B. All right.
Professor, can I ask a question? What is plus E at the end of it?
Plus E means that there is a random error. Okay. That's a random error that is due to unknown variables. Right?
Okay.
Let us say that you and me have the same education. Now, we have 10 years of education, each of us, or we have 20 years of education, each of us. But when you come in to the same place to work and look for a job, your wage might be 90,000 and mine will be 91,000 or 85,000. So that difference is due to some random variable that we don't know. Okay.
Okay. All right.
It could be that the person that the day you came, you didn't look dynamic enough, and so they paid you a little less. Right? Or somebody you were talking and you didn't really show that you could do the job well, and they give you a little more. Or maybe
compensation. Maybe when you compensated.
Yeah, it may also be because
Like
I
when you
really,
make,
I really came to look for the job, but I have a job, and they really want me so bad. And I'm saying, hey, look, if you don't give me this amount of money, I'll just go back to my job. And so, okay, here's the extra money. All right. So those are random variables that we don't know about, and they actually happen. Isn't that
nice.
true?
Yeah, no, very true. There's a good example.
Yeah. Everybody comes in with their own dynamic to negotiate for a wage.
For a wage, yeah. And
You
it
know,
depends on education.
it depends on the situation. It depends on who you are talking with. It depends on how much they want you. You and I can have the same degree, exactly the same degree, looking for a job in the same place, uh, and actually with the same number of years of education, and just minor things can cause your wage to be different from mine. You get the idea? Okay. So now, would it be in order for us to try another example?
Yes, please.
Okay.
Yeah,
I'm gonna try one more example. Okay.
Yeah.
Like I said before you arrived, your exam is gonna be like this. I'm gonna set up all these numbers that you use to estimate. And you do the estimation, you do the interpretation, you do the test of hypothesis. Now remember that in the past, we calculated things like coefficient of determination, and I'm gonna have you do those calculations. You're gonna have all the formulas. You're gonna have all the formulas. So let's try another problem. Okay. All right. So this is another problem. Okay.
I have a question, Professor. For the exam or any assignments, you'll be providing these Y minus Y bar.
I will provide everything.
Excellent. Thank you so much. So
Okay.
this is
I'll
just
provide all the formulas for everything, and I'm going to provide all this summation so that you don't have to go to a spreadsheet and begin to do your own calculations. Okay. I'll provide all of this. Your job is to do the calculation and find out the values and interpret them. And so this is does distance.
Oh, does distance affect the prices of house?
Yes. Does distance from city affect price of house? Okay. All right. So I'm going to make sure we're seeing all of this.
Price of the houses and distance from city. Does distance from the city affect prices of house? Hold on, I'm gonna write this down, Professor. Hold on.
All right. I mean, this is a PowerPoint slide. You're going to have this PowerPoint. Isn't that what we do?
Yeah. When I write it down, remember. Yeah, you're right.
All right. So now we're going to set up the model again. Okay. We're going to set up the model again. What is the dependent variable for this problem?
Oh, Can I say something?
Sure. What value depends on what? What is the dependent variable?
I think I was. Oh, I want to say something. Stay ahead.
Yeah. Okay, go ahead.
Me or me?
Yeah, go ahead. You said you wanted to say something.
Okay, which is dependent to another one. I think distance depends to the price.
Distance of a house depends on the price of the house.
Oh no, okay. I'm sorry.
The price?
The price depends to the distance, exactly.
That's correct.
Yeah,
Okay.
because if the price is in the city, it's higher or something like that different. The price is dependent.
The price is the dependent variable. That is, the price of a house depends on its distance from the city. Okay. So the dependent variable is price of house. Okay. And the independent variable is distance. All right. Okay. So the model we're going to use will be Y, which is price, is a function of X, which is distance, plus E. All right. So this is going to be our model, right? And so the equation will be Y equal to A plus B times X plus E. So we're saying that every house is going to have a basic price, okay? But the further you go from the city by 1 mile, okay, the further you go from the city by 1 mile, does the price of the house change? And the question is B a positive number or is B a negative number? All right. And if B is a negative number, that means the further away from the city, as the distance from the city goes up, the price goes down. If B is a positive number, that means as the distance from the city goes up, the price goes up. We don't know. We have to find out through estimation. So we have to estimate B hat. So we estimate B hat. We estimate B hat. So how do we estimate B hat? B hat is summation X minus X bar over Y minus Y bar. And so we have summation Y minus Y bar times X minus X bar, which we take from here. And is Omar that was asking that question. So you're going to have all these fanciful numbers. You don't have to do your own calculation. You've already done that for your homework assignment. And X minus X bar squared is that.
Professor, this example is taken from one of the assignments, or you?
I think I took it from one of the assignments or one of the illustrations in class. Okay, so what is B hat? Can somebody calculate B hat for us?
Yes. I got negative 21.63.
Very good.
No,
Minus 21.63. All right. So we're going to calculate A hat. which is the intercept. Okay, which is y bar minus b hat times x bar. And b hat is minus 21.63 minus 21.63 times x bar. What is x bar? X bar is 11.62. 11.62. All right. And so does somebody have an answer for me? $1973.35. Okay.
I have 1973.7106.
Okay.
Is that okay?
Yeah, that's correct. That's right.
All right. Okay. I mean, just the way we are plugging the numbers. So I have 1973.35. That doesn't make a big difference. All right. So now we have to write the model equation. Okay, let's write the model equation. That is something that I expect from everybody. Model equation. The model equation is that y, which is the price, the dependent variable, price, is equal to 1973.35 minus 21.63 times x plus e. Okay. So now this is the model equation. The next thing then we're going to do is to test of hypothesis. Now, what does this model equation mean? Okay. What does this model equation mean? Okay. Now, what it means is simply that the price of a house, this is like in the hundreds. So let's just forget about the small value here. Okay, I removed some zeros to make the calculation easy. Okay. So it says that the price of a house begins from 1973.35, and for each additional mile from the city, the price of the house will fall by 21.63. You understand that?
Say that one more time.
Okay, what is it that you want me to say one more time? Interpret this.
Sorry.
The price of a house begins basically if it is like in the city. Right?
Yeah, it starts at 1973.
Yes, and for each additional mile away from the city.
So every mile after that, it decreases by 21?
Yes. Every additional mile away from the city.
That's true. That's okay. Yes. Thank you for clarifying, Professor. Yes. It
All right.
increases away from the city. Yeah.
Yes. So this is what that model means. But again, when you do a statistical estimate, you have to ask yourself, does the estimate of B hat, is it meaningful? It could mean that there's really no relationship. So you want to test the hypothesis that B is equal to 0. If B is equal to 0, it means that the independent variable does not affect the dependent variable. So now we go to the stage where we test hypothesis. All right? So we're going to go and test the hypothesis right now. And we're going to use these values again. So I'm going to copy those values. Test for B hat. I'm just going to call it a B hat here until I go and retrieve the values. Okay. The hypothesis test for B hat. Okay. That is what we're going to do. So how do we test the hypothesis for B hat? The first thing we do, as we all know, is to state the null hypothesis. Okay. And as usual, we're going to now going to reinvent the wheel here. I'm going to take the information from here. Okay, so we say distance does not significantly affect price of house. Okay, and so the null hypothesis is that B is equal to 0. That distance does not affect the price of a house. And the alternate hypothesis is that B is not equal to 0, so distance does significantly affect price of house. All right. Let us test differently now at 0.005. And Z star will be 2.576. Okay. And N is actually 105 here. So and the way we I'm going to again all right. So we're going to calculate. We're going to do the calculation of the process of hypothesis test. Okay, we're going to calculate Z. So this is our null hypothesis, and we're going to now calculate Z. Okay, so we'll calculate Z, very simple. Okay, and Z, going to use only part of this. For b hat, which is the slope. Okay. All right. And so z is equal to what? How do we calculate z for z is equal to b hat minus b divided by the standard error of b hat. Okay, so the standard error of b hat is given by this formula. And we have to go and copy the numbers, which we say the summation y minus y hat squared, and which in this case is that summation y minus y hat squared so we take that and we replace that. So that's what we have. And n minus 2 is 105 minus 2, which is 103. Summation x minus x bar squared. We got from here x minus x bar squared is there. And we take it from there and we replace that. Okay. All right. So what is the answer? The square root of that arithmetic over there. Can somebody give us the answer? Hello?
Yeah, I'm working on it.
We're trying.
We're working
All
on
right.
it.
All right.
I don't know if I'm right again.
Okay, what do you get?
I always get a big number. I don't know why. 31086.
No.
Like that, I don't know why. I'm putting the, maybe I have to put, I don't know. I'm gonna use this different. This square root of 48305492.50. Okay. 48305
I got
192.50
I don't know about 53 point whatever.
Okay.
divided.
I'm gonna do it again. 483.
Maybe 1.483
Divided the square root
Over.
103.
Professor.
Yes.
Be
103.
1.483
No.
2165.562 goes. I have 14.716.
That's correct.
Why I have to always do separate to get the right answer?
What do you want?
Every time when I do it together, the square root of everything, it doesn't give me the right answer. But if I do it separate, then I get it right.
Yes, because that is the way, because sometimes you don't manipulate the calculator correctly. So the best way to do it is to do it one by one. Believe me, it helps.
Okay, you know what I did? I put everything, I calculate everything, then I square root it. I put everything in the square root, then I get it right.
I have 14.83.
Fine and good. Just the way you put in the decimals to change that, but it's 14.716. So B hat, what was B hat? What was B hat?
2.5.
What was B hat?
103.
14. No. Sorry. No.
What was our estimate of B hat?
21.
We had B hat was 21.63, right?
65.
21.63.
62.
21.63. Now remember, we use the absolute value, and our hypothesis is that B is 0, and the standard error of B hat is 14 point. It's 14.716, 14.716. And what is the answer for that?
48305492.5.
1.469. 1.469.
3.
And so this is Z.
2165.562.
Okay. Decision rule and decision. All right. If Z
10156168883.
is Z is greater than Z star, you reject the null hypothesis that distance does not affect price
6883.
if Z is less than Z star. You cannot reject the null hypothesis. So since Z of 1.469 is less than Z star of 2.576, we cannot reject the null hypothesis that distance does not affect price. Now, did you follow the logic?
Yes, that makes sense.
Okay. So this is the logic. Now,
Cannot reject that the price, that the distance does not affect. It does affect. Yeah.
no, you reject the null hypothesis that distance does not affect price, because if B is 0, that means distance has no effect. So that's your null hypothesis. So once you are not able to reject that null hypothesis, what are you saying? You're saying, yes, distance does not affect this price, because you're not able to reject the null hypothesis that distance does not affect price. So let's go back. Let's go back to the null hypothesis.
So that is your conclusion?
That is the conclusion. The conclusion is that we're not able to reject the null hypothesis that distance has no effect. This was your null hypothesis. Null hypothesis, distance does not have effect. And you are not able to reject that null hypothesis. Since you are not able to reject the null hypothesis, you are concluding that distance has no effect on price.
Yeah.
Do you see that?
Yeah. Yes, Professor. So does distance does not affect. We reject H.
What did you say? Did you reject HO or you did not? Hello?
Um. No, we cannot reject.
Okay, you cannot reject the null
Cannot.
hypothesis. So your conclusion is that distance does not affect price.
Yeah. Yeah. Conclusion is that distance does not affect price on.
Yeah, because you were not able to reject that null hypothesis.
Oh, okay. So for example, Professor, you'll be checking for our equation, the model equation.
We're checking for model equation. You're going to calculate coefficient of determination. You're going to calculate coefficient of correlation. You're going to test the hypothesis. You're going to tell me what the hypothesis means in English. The mathematics, you're going to reach conclusion. And you're going to do the other things that we have done for this class. Okay.
All right.
Your test is going to be on the 18th and 19th. In the sense, I will post the test on the night of the 17th or the night of the 18th. I mean, the morning of the 18th, and you have until the 19th to complete the test. Now, if you have been missing homework assignments, please try to do them all. Otherwise, you're going to get an incomplete or you will not pass the class.
Okay.
All right. Any other questions?
Professor, I need to talk to you about something, but
Okay.
privately.
Fine and good. When the class is over, you can stay back. All right, guys. So that's it. That's it for tonight.
All right. Thank you, Professor.
All right. Good night.
Good night.
Good night, Professor.
Good night. That's Inida. So you want to talk with me?
Yes.
Okay. All right. Everybody's out except you.
Yes. So, Professor, I emailed my advisor
Okay.
about the internship, and my advisor advised me to talk to you about the internship.
Okay.
So I need 23 credits more after this semester to graduate.
Okay.
But I don't know about the internship, if we're going to do any internship.
Yes.